What is Arduino? The Arduino Uno was announced on September 25, 2011 at the New York Maker Faire. The model name Uno is Italian for the number 1 and is intended to correspond to 1.0 or 1.0 release of the Arduino software. Previous release number 1 through 22 have been considered alpha or preliminary releases. Over the years, the processor has been upgraded twice, from the original 18MB with 8 KB of program memory, first to the 18MB 16.8 with 16 KB program memory, and then 18MB 32.8 with 32 KB program memory while remaining pin compatible. Technically speaking, the terms Arduino cover the hardware, software, development team, design philosophy, and spread the corpse of the user community. Arduino was originally developed in Ivrea, Italy. Arduino of Ivrea was the king of Italy about 1,000 years ago and is celebrated in local history. The Piazza Gioberti hosts a pub named after this famous king, which some say is only named after the road it's on, the Via Arduino. The name Arduino is a masculine Italian name meaning strong friend. Being a proper name, Arduino is always capitalized. The modern name Uno is stylized in all capitals only in the logo on the PCB. For more on the history and heritage of Arduino, as well as mountain of other fascinating information, please see Arduino website on arduino.cc. The Arduino Uno I/O board. When most people think of Arduino, they imagine the small, rectangular, and probably blue printed circuit board PCB. This is properly called the I/O board. The I/O board is the physically tangible part of the Arduino system. The Arduino I/O board has traditionally been based on the 18ML AVR8 and later derivative. The I/O board also contains a serial port, power supply circuitry, expansion connector, and miscellaneous support components. 18MB 32A processor is an AVR and is a programmable microcontroller chip. 18MB 32A processor is an 18MB 32A PU, the first P being the pico power technology and the second P meaning plastic dip dual inline package, which is the type of package encapsulation of this chip. A surface mounted version of the Arduino Uno is available too. The power supply circuitry. The power supply circuitry has seen some refinement with extra overcurrent protection and intelligent power supply selection. Expansions connectors. The port follows the physical distribution of the pins on the chip itself. USB to serial port. The serial port is used to communicate. In the development stage of your Arduino project, the communication is between the Arduino and your PC, where you're writing, compiling, and uploading your sketch to the I/O board. In the application or deployment phase of your project, when your Arduino is performing its intended purpose, the serial port may continue to communicate with your PC if that is part of the plan, or it may communicate with another serial device. The use of the serial port is optional at the application stage, so it may be communicating with nothing at all. If this is the case, the receive RX and transmit TX pin can be used as general purpose input-output lines. 3 general purpose I/O ports. In AVR parlance, the ATmega8 family, of which the Arduino Uno's ATmega32.8 is a derivative, has 3 general purpose I/O ports. On the ATmega8, these ports are named Port B, Port C, and Port D. Each port have a maximum of 8 I/O pins associated with it. With the purpose to never forget again, mark the Arduino name position. Below is the A, that is the power bus. Above B, you start C and D. See? The I/O board's expansion connectors allow additional circuitry to be easily connected. One of the buried technical details of the Arduino is the naming and grouping of I/O pins within the expansion connector. In Arduino speak, the pins are simply numbered V0 through V13, and the 14 digital pins and A0 through A5 for the 6 analog pins. The digital pins run along the top edge of the board, and the analog pins are on the bottom edge. This naming convention, although widely adopted and referenced extensively in the Arduino documentation and software, is both misleading and inaccurate. Some of the digital pins provide the analog output pins 3, 5, 6, 9, 10, and 11, but are in reality pulse width modulation (PWM) or purely digital output. The analog input can just as easily be used in exactly the same manner as any of the other digital pins, either as digital input or as digital output, but never as analog output. Arduino PINOUT will be taking a closer look at the Arduino hardware, and more specifically the Arduino Uno PINOUT. Every one of the general purpose I/O pins on the ATmega32.8 has an alternate peripheral function, which can be selected in software. The versatility of the PINOUT provides many different options, such as driving motors, LEDs, reading sensors, and more. For example, the red pins are all PWM and digital at the same time. This one belongs to the interrupt routine 2. Both the Arduino and the AVR naming conventions work quite well for their intended purpose and provide a nice overlapping symmetry to the circuitry design. Arduino multiplexed pins. The serial port are pins RX and TX. Pin 2 on the 28-pin DIP from the AVR side is called PD0. I/O port D bit 0. RXD receive data input pins to the UART peripheral, as well as PC int 16 pin change interrupt 16. From the Arduino side, it's called D0, digital pin 0, or RX. How much current can I draw from the Arduino's pins? Basically, there are a number of limiting factors. The lines from the microcontroller have both an aggregate current limit and a per pin limit. In summary, The absolute maximum for any single I/O pins is 40 milliampere. The total current from all the I/O pins together is 200 milliamperes max. AVR architecture interfaces to pins. There are 20 digital I/O pins. They can all be used as traditional 3-state digital interface. Many pins have additional capabilities as indicated in the previous slides. Each pin's directly programmable program direction, program value, and program pull-ups. Some pins are special, analog versus digital, clocks, and reset. Arduino pin circuitry under the hood. Each port is controlled by 3 registers, which are also defined variables in the Arduino language. The DDR register determines whether the pin is in input or output. The port register controls whether the pin is high or low, and the pin register reads the state of input pins set to input with pin mode. There are 3 8-bit ports, B, C, and D. How to use the whole 8 bits of a port? Port manipulation is the answer. Port register allow for lower level and faster manipulation of the I/O pins of the microcontroller on the Arduino board. As seen previously, the chips used on the Arduino board have 3 ports: B digital pins 8 to 13, C analog input pins, and D digital pins 0 to 7. Each port's pins are controlled by 8 bits. The Arduino bit fields are arranged like this in each port. Bit numbering, or sometimes bit endianness, is the convention used to identify the bit positions in binary number or a container for such a value. The bit number starts with 0 and is incremented by 1 for each subsequent bit position. The least significant bit, LSB, the LSB is sometimes referred to as the rightmost bit due to the convention in positional notation of writing less significant bit further to the right. The most significant bit, MSB, also called the right order bit, is the bit position in a binary number having the greatest value. Register DDR determines if the pin is in input or in output. 1 output, 0 input. This means direction. Register port control if the pin is high or low state. 1 high, 0 low. This means states. Great. Now let's recall some key points of the topic through questions and answers. Here is question 1. Which register is responsible for pin direction configuration, whether input or output on Arduino board? The answer is B, DDRX, which is a data direction register. Good. Now 2. Which register is responsible for the pin state configuration, whether high or low on Arduino? The answer is A, port X, which is the control byte if the pin is high or low state, 1 high, 0 low, good. And the last one, 3. Which register do we write in 1 to a bit will result in a toggle in the corresponding bit in the data register? The answer is D, pin X. Writing a 1 to pin X toggles the value of port X independent on the value of DDR-X. The SBI instruction can be used to toggle one single data bit in the port. See datasheet pages 98, 99. Good. Summary. DDR-X direction register defines whether a pin is in input 0 or in output 1. Port X pin output value. Writing this register sets value of pin. Pin X pin input value. Reading this register returns value of pin. There you have it. In the next lecture, let's dive into the bits and bytes of the Arduino. Do not miss the next event. We're gonna look at every graph on the 18MB32AP datasheet. Bye for now.